In the second video on random variables and probability distributions, we are going to be talking about the topic of probability distributions. So as this says, for any random variable, there is a corresponding probability distribution that describes the probability that the variable will take on any particular value. And it says that probability distributions for a discrete random variable can be represented as a table, a graph, or later as with an equation. So let's go back to our probability experiment that we had for tossing two coins. And we said that x can take on the values 0, 1, and 2. And so we can see those outcomes right here. So x is the number of heads, possible outcomes 0, 1, and 2. What we want to do now is to find the probability that x will take on any of these little x values. In other words, the first one we're going to be doing the probability that x, remember capital X is our random variable, equals 0. And then the next one we're going to be doing is the probability that your random variable equals 1. And then finally the probability that x is equal to 2. So if we go back to our tree, all right, and we put some probabilities on that tree, we can see that, this is a fair coin, so you have a half a chance of getting each of those, half here, half here, half here, half here. And so each of these probabilities turns out to be 1/4. All right, but remember that our random variable x, in this case when it was heads, heads, was 2. And in this case, heads, tails, and tails, heads, the random variable was 1. And then this one, the random variable was 0 because there were no heads. So if we want to find what's the probability that x takes on the value of 2, well, that's just going to be 1/4. And so in our probability distribution, we can put that the probability of getting 2 heads is 1/4. The probability that x is 1, that we get just 1 head, is either this one or this one. So that's 1/4 plus 1/4, which is 2/4, which is 1/2. So we're going to put that probability in here, 1/2. And then finally, the probability that x is equal to 0. I know I've done this in the reverse order. It doesn't matter which order you do it in. X can take on the value of 0 when we get tails and then tails. And the probability of getting tail and a tail is 1/4. We already saw that. So there's only one chance to get that. Okay. So that's one way to represent what's called a probability distribution. It shows what are the probabilities that your random variable can take on those particular values, 0, 1, and 2. You can represent this with what's called a spike graph. If on the horizontal axis we put x, which is the number of heads, and then on the vertical axis we put the probabilities. Now remember, probability can't go over 1. 1 is the highest probability that you can get, but it can go down to 0 also. So we've got 3/4 in here, it looks like, 1/2, and 1/4. And then our values that x can take on are 0, 1, and 2. So we're just going to do a little spike that will just show the probability that x is 0 is 1/4, and that's just right up here. So we're just going to do a little spike. The probability that x is equal to 1 is 1/2, so again a little spike. And the probability that x is 2 is 1/4. So that's what's called a spike graph. Again, just another way to represent the probability distribution. And then the last one is with a column graph. So a column graph is very, very similar to what we just did. You are still going to have probabilities on your vertical axis from 0 up through 1. Not sure why I'm writing those as decimals when I wrote the other ones before as fractions. It does not matter. So we've got 0, 1, 2. And so when we do the bar graph for this, or column graph, we'll just have a bar for 0 that goes up to 1/4 or 0.25. For 1 goes up to 0.5. 2 it goes up to 0.25. So one of the things that you should have recognized here when we find all of these probabilities is that they're all between 0 and 1, right? Because we know that probabilities have to take on the values between 0 and 1. But notice that also that they add up to 1. So we have 1/4 plus 2/4 plus 1/4 is equal to 4/4, which is 1. All right? So what that's just saying is that one of these three things has to happen. You either have 0 heads, 1 head, or 2 heads. All right, that takes up everything. And so those probabilities should add up to 1. So that's what this is a statement of in this box. Characteristics of probability distributions for random variables. So this says if x is a random variable with sample space x sub 1, x sub 2, x sub 3, all the way up to x sub n. Remember, sample space is just the list of the possible outcomes. And corresponding probabilities, p sub 1, p sub 2, p sub 3, all the way up to p sub n. So when they say corresponding probabilities, what they're talking about is that the probability that you get x as an outcome is x sub 1 as an outcome is p sub 1. And the probability that you get x sub 2 as an outcome is p sub 2, and so forth. All right, so anyway, so we have x as a random variable with these are possible outcomes. These are the probabilities of each of those outcomes. Then it says to notice that if p, or the probability that x is equal to x sub I is equal to p sub I, all right, that's just saying probability that it's x sub 1 is p sub 1, and so forth. For all I equal to 1, 2, 3, all the way up to n, it's just saying it works no matter what n is. Then there are two properties. One is that the probability, each of the probabilities have to be between 0 and 1 for all I equal to 1, 2, 3, all the way up to n. And then we also said that the sum of the probabilities, adding those numbers up, had to add up to 1. So the sum, and this is notation that I'm sure you've seen before, but maybe not recently. The sum for I equal 1 to n of p sub I. So what that means, the way that you work that, is you take I equal 1, and that's the first value you put in here. And so when I do that, I get p sub 1. All right, then I'm going to let this value of I take on values, integer values, all the way from 1 up to n. So we've let I equal 1 to start with. Now we're going to let I equal 2. So when I put 2 in, I get p sub 2 plus. Now I go back here, I bump I up by 1 more value, so that's p sub 3 plus dot, 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 and it goes all the way to when your last value is n. So up to p sub n, and we know that all those probabilities have to add up to 1. The last piece that we have, and then we're going to go on to some examples, is just notation. So sample notate, and this is actually incorrect. That was from our old book. But some notations that you might have when you're calculating probabilities. This just means the probability that x is equal to 3. This one says, what's the probability that x is less than 3? This says, what's the probability that x is between 3 and 7 inclusive, basically. So we'll stop here, and we will do